Hello everyone, my name is Tarayan Inessa, and today we're going to discuss the second homework of the course Database Systems, which is about ERDs and relational schemas. So let's go ahead and jump in. Okay. So first of all, I want to show you the problem, and then we're gonna go ahead to see the solution. The first question, there is a pool of multiple choice questions from which questions are chosen for an exam. Each exam has its own ID, title, and date. Each question is identified by an ID, has multiple answers, but has only one correct answer. Okay, so first of all, we're going to discuss the ERD, which is Entity Relational Diagram. So the diagram itself looks like this, and let's discuss the details. So we will have exams, we'll have questions and answers. So definitely these three are going to be separate entities. So first of all, we have exam, which has primary key of exam ID, title, and date. I marked them to be not null. And another entity that we have is questions, because we have pool of questions from which we're going to select some questions for our exam. And there we're going to have just an ID to identify the question uniquely, and the title. It's like the formulation of our question. Then, since we have questions, each question can have many answers. For example, it can have 4 or 5 answers, and one of them will be correct. And for that reason, I separated an entity for answers, and there we have answer ID and answer text. Also, for exam, I separated rooms, because exam will take place in some room, and we'll see the relation. So let's start looking at the relations. Exam and question. So exam contains question. This is an identity relation because if there is no exam, there are going to be no questions. And yeah, if we have no questions, definitely we don't have exam. Yeah. So this is a many-to-many relation, obviously, because exam can have many questions, can contain many questions, and the same question can be used in different exam tests. For that reason, we're going to have many-to-many relationship, and in such cases, we're going to have another table which will represent this relationship. Furthermore, we will need to have relation for questions and answers. So I separated these two. I will tell you why later on. So question has answers. Again, same story. One question can have many answers, and the same answer I thought that maybe can be used in different questions. So maybe we have some different formulations, and the answer for them can be like the same. That's why we can reuse these answers. This is the idea. And again, here we're going to have this pivoting table to represent many-to-many relationship. And here, in addition to that, in the table, we're going to include answer number, just to uniquely identify the order of these answers inside a question. Yeah, this is it. And now let's talk about this relationship. Question has one correct answer. So the problem why we can't fit in somewhere in here, because question will have one and only one correct answer. But the same story here, that certain answer can be correct for a couple of questions, let's say. This means that we have one-to-many relationship here, and we'll see how it goes in the table. And about the last one, which is relating to exam rooms. So we have many rooms in the room table. and which contains the ID, room number, and notice that here it should be not null and unique, because, for example, 313 West is the room number, and it should be unique because we have just one room with such number. And why didn't I put it as primary key, you might think. The reason for that is because it might be changed, and usually it's not a good practice to do that. And maybe it's better to have it separated, just to keep separate ID. And room capacity. I don't know. It can be optional. That's why it's nullable in this case. It can be null. And the relation between this is the following. Exam happens in rooms. Each exam can happen only in one room, because let's say database systems midterm can take place in one room, and all of us will come to that room. But in that room, we can have multiple exams at the different period of times. That is why this is a one-to-many relationship again. So this is the entity relational diagram, and now let's see the relational schema. Actually, I like also drawing the actual tables that we're gonna end up with, but this time I just went with the schema and not the actual tables. So yeah, this one. Let's discuss it. Here we have the same tables, but with one addition, question answers. And if you remember, this was the following many-to-many relation. And let's see. So we have exam, where exam ID is our primary key. We have a room ID, which represents this one-to-many part. And we'll have title and date, and which are not nullable, not null. And room ID here, notice that it's a foreign key coming from the room table. Now, inside rooms, we have the room ID, room number, which is not null and unique, and room capacity. I don't know why, but I forgot to put primary keys here. Then questions. We have the ID, title, and now notice this relation has one correct answer. I decided to stick with this approach, and I just put correct answer ID as a foreign key in my questions table. And it's coming from answers table. So this references to this. Okay. Now we have answers table with answer ID, as you have seen, and answer text, which is not nullable. And finally, we have our many-to-many relationship, which is this one. And we have here question answers. And we have question ID as a foreign key, answer ID as a foreign key, and answer number, it is this one. But I guess we forgot something here, and I will add it right now. I actually forgot to put exam questions here. So let's add it. I just noticed. Exam questions, and here we will need to put the following. So exam ID as a foreign key, question ID again as a foreign key. Yeah, and that should be it. So in this table, we're gonna have, for example, we have exam ID 1 and questions 3, 4, 5, 6, 7, and we'll have 1, 3, 1, 7, and this means that 3 and 7 will be appeared in our exam number 1. So this is the idea of relational schema. So let's go to the second problem. Okay. A building has different rooms, a room has different facilities, but a facility belongs only to a certain room. Note that we only purchase a facility if a room needs a facility. So in this case, we see that a facility will always need to belong to some room. And let's check the ERD. Okay, this looks pretty big because I added a couple of things, but let's begin with the first one. So we have building. Building ID is a primary key, address unique and not nullable because in one address we can have only one building. Name, and I decided just to keep manager name and the manager phone. I guess this could be separated. Maybe we have a couple of managers, but let's just don't make it complicated. Let's keep it like this. We have email, unique and not nullable, fax, and OpenZ, closez, again, nullable. I don't know why. It's just a matter of approach. Actually, in real life business examples, of course, we're going to be provided with some information that maybe this must be always there, not nullable, but in this case, we can just decide on this together. Other than that, our building will need to contain room, and rooms will be identified by their unique primary key, room ID, and we have room number, again unique, with the same logic as we discussed in the previous example for 313W, let's say. And room capacity, again optional. Now we will have facility, so room will own some facility. I decided to do it this way. I will have facility with its own unique ID, facility name, which is going to be not nullable, and we're going to have facility type. Sorry. An example of this will be, for example, type whiteboard or a type chair, let's say, and for that reason it should be unique. Facility can have only one type. Let's notice that it can't be whiteboard and chair at the same time. Other than that, we're gonna have, I decided that maybe facilities will have their managers, people that will track these facilities, in which room they belong to at the moment. So these people may be responsible for rotating these facilities in the room. So I decided that maybe this might be useful as well. So it has ID, name, email, and phone, which are all not nullable. And yeah, other than that, I decided to have room types because maybe it's gonna be like classroom or an auditorium or lab, I don't know, or an office. So I don't know, this information might be useful as well. And for the same reason, it should be unique. Now let's see the relations. So building and room. Building can have one or many rooms, definitely, but the same room can belong only to one building. So for this reason, we're going to have many-to-one relationship. Other than that, our room can have one and only one type. It can be either an office or an auditorium or something, but the same room type can be used for many rooms, apparently. So that's why, again, here we have one-to-many relationship. Regarding the facilities, our room can have one or many facilities. Actually, this can be zero or many. Yeah, but I don't know. Let's just keep it this way. And from the other side, the facility can belong to one and only one room. Yeah, this is the idea. So we have a many-to-one relationship here. Yes. Okay. So about facilities and facility types. So facility can have only one type, but the same type can be used by many different facilities that we own at university. For example, university. And regarding the manager, facility can have only one manager, but the same manager can manage many facilities. So many to one relationship. This is it. Now let's look at the relational schema, which is here. So we have building ID, the same, everything is the same as we have seen. We have, it's like address, name, manager name, whatever we had in here. Then we have rooms. We have room ID, a room number, room capacity, and everything is the same until this point, but we have some additions here. We have building ID as a foreign key. This is because we had, as you remember, we had many to one relationship, and it's obvious that we should keep this foreign key inside our one part. And in the room, we know that this room will belong to building ID number 5, let's say. And the same regarding this room type ID. We had one side to room. It's like one to many two room types, and that's why we will have room type ID here, because we're gonna have just only one type, room type. And room type is with no additions, same as we had, just ID and type. Now the facilities. We have ID name, just as we have here, and the additions are the following. We have facility type ID. This is the same example with the room type, and we have manager ID. Again, one side is into facilities. That's why we put it inside facility table. And we have facility types, which is the exact same as we have here. And we have facility managers. This is the following. Here we have manager ID, name, phone, and email. So everything should be the same. This is the problem number 2, and let's go to the problem number 3. A course is an entity, part of our university system. A course must have an ID, unique course code, such as CS222, description, and credits. Don't worry about department and its association. A course might have prerequisite courses. Okay. Let's go to the ERD. It's this one. Okay, this is a very interesting one. You'll see why. So we have courses. Actually, this should be courses, but okay, whatever. We have primary key to uniquely identified one each course. We have course code, and it's not nullable and unique. It's because, for example, CS213 course is only used for one course, so it's unique to it. We have description and credits, and all should be not nullable. Other than that, I decided to actually worry about this department and add it. So we have department, for example, it can be computer science department or engineering sciences department, and each of them will be represented by unique ID. They will have name and they will have dean, and all of them should be unique. So this means that the same person cannot be dean for many departments at the university, in this university, let's say. And I decided that department will have department codes, and this is a one-to-one relationship, because departments can have only one department code, and department code belongs to only one department. And this is about, for example, our computer science faculty. And the department's shorthand will be like CS, and all of the courses that belong to this department will start with CS. So this will make our life easier to separate it. And here we'll have ES or BAB, if I'm not mistaken, it's called like that. And let's see the relations together. So the first and most important one is the prerequisites. So the course will be in a relation with itself. This is like a recursive relationship, and it's going to be many to many, because a course might have many prerequisites or no prerequisites, and a same course can serve as a prerequisite for other courses, no course or many courses. So in this case, since it's a many-to-many relationship, we're gonna have another table, but both prerequisite and course IDs are gonna reference to the same table. So this is called like recursive relationship. Now about the department. So course belongs to one department, and this means that database system course cannot belong to, let's say, English and communications department. It just only belongs to CS department. And that's why it's one-to-many relationship, because the same department can have many courses. And this one we already talked about, since it's a one-to-one relationship between departments and department codes. And let's see the relational schema, sorry. So we have course. So it's ID, course code, description, credits, everything is the same besides department ID. This is a foreign key, and the logic remains still the same, that one side, one-to-many, one side is belongs to course. That's why we put this foreign key in here, because course can belong to only one department. Next, we have course prerequisites. This is the pivot table that I was talking about, and it represents our many-to-many relationship. And here we have course ID, prerequisite course ID, and both are going to refer to the same, exact same table. Next, we will have departments with ID, name, and dean, and department code ID. And department will have only one department code. That's why we put it in this table. And we have department code, which is ID and code, just as we had in here. So no additions. Okay, so this was the problem number 3, and let's go to the 4th one. In a movie theater, a movie is played in different halls at different schedules. Daytime. Okay. Let's discuss the ERD. So we have movies. We have movie name, which is unique, and a director. I just thought that, okay, let's add it, and we'll represent the movie with its unique ID. We can actually add here a lot of things like actors and other stuff, but I decided not to complicate it and stick to the main logic. So we're gonna have halls, because a movie will be shown in some hall, and we will have hall ID, which will uniquely represent that hall, and location and name. Both of them are going to be unique. About name, this is about, like, for example, in Moscow cinema, we have like red hall or a blue hall, if I'm not mistaken. So this is about it. And about this, so time periods, I decided that in my cinema, all of the movies are going to present it in the in different time slots, but the time slots are going to be the same. For example, we have time slot like 10:30 in the morning, then 1:30, 3:30, 5:30, and these are going to be like time slots. And we're going to keep some gaps between the holes to do all the cleaning and stuff. And these time periods are actually going to be put in this table. So we're going to have an ID, start time, and date time. But please note that this only refers to time and not day or year. Let's see the relations already. So movie is played in some hall. The movie can be played in different halls, and in the same hall we can stream many movies, but of course in the different times and dates. That's why this is going to be a many-to-many relationship. And inside this many-to-many relationship, we can specify the start date, which is going to represent the year and the month and the day, but not the time. And also we can specify the fee, how much the movie costs to go and watch it. And this is going to be in relation with time periods. Here it's going to be like one-to-many relationship, because each, I'm going to call this, there is a good word in Russian, but I don't know it in English, so let's say it's seance, each streaming of this movie. Sorry for not knowing this word. So each time we show this movie in some exact hall and in some exact date time, it's going to be unique. And that's why it's going to be like one-to-many relationship. And from the opposite direction, it's in a way that this time period can be used for streaming many movies. I hope it's clear, my point, and let's see the relational schema. So we have movie ID, name, and director, the same identical way. We have halls, we have hall ID, location, and name. Again, everything's the same. Time periods, ID, start time, and time. It's again this one. And we will have one pivot table for many-to-many relationship. I decided to call these streams, but I'm not sure whether it's a correct word for it or not. But let's have it. So inside it, we're going to have movie ID, which is a foreign key, whole ID. So which movie, in what place, start date is at what year, month, and day, fee, how much it will cost, and time period ID, so in which time interval from our table, which is a foreign key. I hope this makes sense for you, and this was the problem number 4, and let's check the last one. A software is identified by its name and has a description. It has several versions, and each version corresponds to a date. Each software has one test suite, which cannot exist without the software. Okay, let's check the last ERD. So we have a software with ID, name, and description. We have versions, uniquely represented by an ID. We have a name for each version, or better, we will say like release tag. Okay, let's keep it like name. We'll have date, and we'll have version repository tag. This is actually about that whenever we release some new version of our app or website or whatever we have, usually like we're gonna have some version tags in our repository. So this is that to uniquely identify our release. And we're gonna have test suites, which will be unique with ID and name, and test suite will contain tests, and it will have ID, name, and test commit hash. I decided to keep it because maybe we have it somewhere in our repository, and we just uniquely identify it with its commit. Maybe it is not a good idea, but let's have it. I think this is not a problem for now. So the relations. We have many-to-one relation with software and version, because software obviously will contain many versions, but the same version will be unique to only that software. Yeah, this is about it. And this is an identifying relation, because if we do not have any software, we are not going to have any versions binded to those. Now about the test suite. So it's one-to-one relation, because a software will have only one test suite, and the test suite will belong to only that particular software. So again, an identifying relationship, because if no software, then no test suite. Then test suites can actually, this is a one-to-many relationship. Sorry, many-to-many relationship. And why I decided it to be like that? Because maybe the same test can be involved in different test suites. That's the logic behind. And the same test suite can contain many tests. That's why this is going to be a many-to-many relationship. But the thing is that here at least we should have one test, because if we have a test suite, then at least one test should be there. But maybe we have some tests in our project that are not involved in any particular test suite for now. Don't judge me for this, but the logic is like this. And let's see the relational schema. So software, ID, name, description, and addition here is test suite ID. Again, because it's one-to-one, and we'll just keep it here. Then we'll have version, ID, name, date, version repository tag, and software ID. Why we have it here? Because we know that this is a many-to-one relation, and one side is in version. So we keep the software ID to know this version belongs to which software. And then we have a test suite, which has ID and name. Everything's the same here. We have tests, test ID, name, and test commit hash. Again, the same, as you see. And here is the pivot table for representing this many-to-many relation. And it contains test suite ID. I wrote this word wrong in all places. And we have test ID. And yes, this is our relational schema. And this was our last problem. Thank you very much for listening to this. I hope it was clear, and I hope it makes sense for you. Have a good day. Bye-bye.